Hello, everybody. Good afternoon for this session, Integration of Petrochemical and Refining. In this session, we will have as a speaker, Mr. Brian Heasley, Refining Technology Manager for KBR Refining Technology Solutions. He is responsible for developing, marketing, and licensing efforts related to KBR's proprietary technologies. Mr. Heasley has over 12 years of experience in the refining and petrochemical industry, spanning process technology licensing, catalyst and absorbent sales, technical service, project management, and process design. He holds a bachelor's degree in chemical engineering from Purdue University, a master's degree in chemical engineering from University of Houston, and an MBA from Texas A&M University. Please enjoy this presentation from Mr. Brian. Thank you.
Welcome, thanks, Luis, for the introduction, and thank you for all in attendance today. I look forward to discussing refinery petrochemical integration and answering your questions at the end. So let's begin. So the title of my talk is Refinery Petrochemical Integration and Maximizing the Use of Existing Assets to Shift to High-Value Petrochemicals. So as we look at the agenda here today, we're going to answer a series of questions to address that challenge. And the first one being, why should refiners explore integration? So what are we seeing in the market that's indicating this shift and why you should look into integration? Next, the question is, what is integration? If you can back up one slide, please. What is integration? So we're going to look at what streams and technologies are typically involved in refinery petrochemical integration. Then we'll look at how KBR can deliver an optimal solution. So KBR has many technologies spanning both refining and petrochemicals. And we'll look at the streams typically involved between the two sites where they're actually integrated. Then we'll look at what are the considerations both on infrastructure and economic. And then we'll look at potential solutions. So we have a series of case studies that we've developed specifically for you all today. And they are centric to refinery configurations common in Latin America. Next slide. So the first question, why should refiners explore integration? Next. So as we look at the global market right now, we can see that the demand for plastics and the production for plastics is increasing and is expected to continue to increase through the foreseeable future. So here we're showing the demand for plastics out through 2050. You've got a number of different types of plastics here. And on the right side, what we can see is a percentage of crude oil going towards different markets, so chemicals versus transportation. And what we see is currently predominantly crude oil is going towards transportation, fuels, but in the future, we're seeing an increase in the percentage of crude to chemicals and a decrease in. So there will be an inflection point potentially in some regions where more crude will be going to chemicals in the future rather than fuels. Next slide, please. So what are the site-specific drivers if you're a refiner? First of all, it's a path to improvement. It can increase your margins, your resiliency of the refinery. It's an enabler to monetize low-value streams. So you can take residue, fuel gas, and potentially monetize that to chemical value, which is a large margin uplift. It's a way to respond to regulatory pressures. So as you find certain streams may violate specifications, maybe you can upgrade that stream to chemicals and remove it from the fuels pool. It's a way to diversify and shift to the future. So as we saw from the demand graph, petrochemicals is the future. It's also a way to diversify and hedge exposure to cyclical markets. So a lot of times there's cyclicality in both fuels and petrochemicals. If you're diversified in both, you can really hedge against those peaks and troughs. And finally, there's single site synergies between two sites potentially with refinery and petrochemical assets. So there's an ability to reduce overhead, and there's synergies between utilities and other things that can really make a site more efficient. Next slide. So I talked about the resiliency of an integrated refinery. And here on the graph on the left, we show the margin of several different products within the refinery. You have gasoline, diesel, and naphtha. The bottom bar of this graph is the crude oil cost. So yeah, as we look at the margins between these products, we can see that gasoline and diesel margins are strong, particularly when you go to retail market, you gain a little margin. However, if we compare this to naphtha margins, we see a much larger margin that can be realized going to ethylene and even polyethylene. The graph on the right is showing the change in margin that we've experienced from 2019 to 2020. And as you can see, the fuels margins reduced in the challenged market during COVID. And we can see petrochemicals actually increase. So both the margin and the relative change in margin, we've seen a resiliency in petrochemicals over the last few years. Next slide. So looking at the big picture, change is coming, and it's really here. I think we've seen COVID accelerate some of this change. Our message is to be proactive, to look into integration now, to gain an edge, because many are already integrated. Many large players in the market, the fully integrated producers, have an edge. So those that are proactive now will have somewhat of an edge into the future. So the change is here now. The middle column here, there's no one size fits all solution to integration. So what I mean by that is some refineries are more gasoline production oriented, and some refineries are more diesel, distillate, jet fuel oriented. Each refinery will have its own unique solution. And then there's a lot of considerations with that. So looking at there's a lot of considerations with that, looking at your existing site constraints, your infrastructure, what low value streams you have, what is your budget, what is the local market for different petrochemicals products. And really with this, all options should be explored. We recommend you look at not only the existing streams within the refinery, but also potentially external streams, maybe even taking it to full derivatives production. So making polymers or other derivatives, and seeking partnerships as well. So you may have nearby petrochemicals sites that are already making certain derivatives. Can you produce a base chemical that aligns with their derivatives production? And partnerships could also involve investment partners as well. The bottom line here is KBR has a very broad portfolio to help with integration. And we have a lot of experience in both refining and petrochemicals to help you get to the future. Next slide. What is integration? Next. So here's some of the typical technologies and streams involved in integration. On the left, we have the typical refining technologies, so reformer, BTX extraction, hydroprocessing, FCC. On the right, we have the typical petrochemicals technologies, steam cracking, on-purpose olefins production, whether it's PDH or MTO, BTX, purification, PX production, and derivatives plants that go along with that as well. And you can see the typical streams integrated between the two. So you've got hydrogen, mixed C4s, potentially heavy material from a petrochemical site. So you have some streams coming back to the refinery that can be monetized, and vice versa. You have many LPG type molecules that can be cracked to olefins and petrochemical sites. Naphtha can also, and even gas oil. So there's some synergies between these two sites. And also on the bottom line, there's energy and utility savings too, integrating the two. So there's really a lot of opportunity to gain efficiency by integrating these two traditional sites. Next slide. So if we look at different levels of integration, there are several different levels. And this graph shows the benefits versus complexity. As we incrementally add more integration to petrochemicals, there's more benefit, but it comes at a cost. So if we go through each one of these, minimal integration is a refinery that's producing maybe refinery grade petrochemicals, no derivatives production, little to no integration with petrochemical sites. As we move to the next stage, partial integration, this is where you may modify existing units to boost petrochemicals make. So an FCC adding a secondary riser to increase propylene make. You may be increasing it at this stage, but you're maybe not producing high purity products, so the polymer chemical grade products. There could be modifications to your gas plant if you're talking about an FCC for higher recovery. And there could be some minor integration with petrochemical sites. Here we show some typical technologies that KBR offers maybe at this stage of integration. At the major level, you're really looking at adding traditional petrochemicals conversion units to the refinery. So those would be like steam cracking or on-purpose olefins production. At this level, you may also be producing derivatives. So polypropylene or polyethylene, for instance. You may also be highly integrated with local sites, petrochemical sites, in their derivatives production. The last stage on here is full conversion, and this is what many call crude oil to chemicals. So this is really pushing every last drop of crude oil to chemicals production. Typically, these are world scale units or complexes because of economics. They are purpose built, single site, and they offer full conversion to derivatives. And this is a major capital investment. We are seeing some of these complexes being built around the world, but it's not for everyone. And this is a major investment. Next slide, please. Another important concept to cover when shifting to petrochemicals along that spectrum is phasing investments and really stepping along that complexity benefits curve. So here we show for an FCC ways to stage your investment. If you look at a fuels FCC, it's maybe producing 4-6% propylene. We can boost that propylene make by changing catalysts, by doing certain things, but then we hit a limit. And the next stage is really adding a secondary riser that enables you to crack to higher propylene make. You can get to 8 to 12% propylene with that riser, maybe without modifications to the gas plant. The next stage, moving to the right, would be modifying your gas plant and making it larger. You can get upwards of 20% propylene at this stage. And additionally, you could add ethylene recovery. So you could add a cold box for high purity ethylene production. And you can also look at adding a KSAT unit, which is KBR's solid acid alkylation unit. That enables you to monetize the ethylene to alkylate, which is not petrochemicals, but it's a way to increase the value of your fuels pool to a high value alkylate, which is one of the best gasoline blending components. Next slide, please. What are the considerations? So the first set of considerations is on infrastructure. And you want to look at your existing assets. Are you an FCC-based gasoline refinery? Are you a distillate hydrocracking-based refinery. That will determine which path you should go down and what modifications you need to make. You also want to look at your site constraints, so plot space, utilities, also the proximity to petrochemical sites, and what sort of products are those sites making. So you want to, if you're not going to full derivatives production, you want to ensure that your value chain aligns with the sites that you're sending product to. So there's a lot of consideration on the infrastructure side, and then pipelines, obviously, port access, these sorts of things can enable you to get to a market maybe that isn't local. Geographic region is also important. So you have to look at where you are in the world and what are others doing in that region, and can you be competitive with them? So one example would be on the US Gulf Coast. There's a lot of petrochemical capacity. It's very difficult to compete with some of these world scale plants. So maybe you look at producing a different product, a different derivative than that they are, and find an advantage there. So these sorts of things need to be looked at all over the world. Next slide, please. Next, there's economic considerations. So can you upgrade low value to high value? That is a large uplift in margin. So residue to olefins is one example where you can really gain an economic advantage. Use of existing assets in the top middle there. Can you change or modify what you have? And if you can, that's typically a cheaper way to get to petrochemicals and get a high return on investment. What is your budget is an important thing to consider. Can you phase investments as well? On the lower left, it's important to balance fuels and petrochemicals. So here we use an example of alkylate versus polyethylene polypropylene. So it's important to make sure you're still producing high value, high demand components on either end of the spectrum to really maximize your economic return overall. And then finally, a couple points on market, and you want to make sure you can access the market. Is it a sustainable market? Are you projecting growth with that market? Those are all important things to drive return on your investment. Next slide, please. So we're going to go through KBR's portfolio quickly here. Next slide. Next slide, please. So the first technology that I'll talk about is SCORE, our steam cracking technology, and that is taking a full range of feedstocks to petrochemicals. And you can see the feedstocks on the left, the products on the right. Next slide, please. K-Pro is our on-purpose propylene production unit, so taking propane dehydrogenation to propylene. Next. K-COT is our advanced naphtha catalytic cracking technology, and that takes C4s and naphtha and can produce petrochemicals. Next slide. Aromatics extraction, AED BTX. So this can take a naphtha stream and extract B, BT, and BTX. Next slide, please. Next is Maxifin, our high severity olefin producing FCC technology. So this can take a full range of naphtha, diesel, gas oil, and produce petrochemicals. Next. So ROSE is our supercritical solvent deasphalting technology. And while this doesn't produce petrochemicals, it enables conversion of residue to a intermediate stream that can be diverted to petrochemicals. Next. And then finally, VCC. Again, this is an enabling technology. It doesn't produce petrochemicals, but it does convert residue to intermediate streams. Next slide, please. So what do solutions look like? We'll go through a couple case studies here. And what we did is we looked at Latin America and a survey of refineries. And what you find is that many are FCC delayed coker based refineries. And so they're producing a lot of gasoline. And so our cases are aligned with this particular configuration. So next slide. So the first one is adding a couple technologies and integrating with petrochemicals by boosting the feedstock and improving the feedstock quality to the FCC unit. So here we've added an SDA unit, ROSE. We've added a hydrotreater, FCC pre-treat unit, and those are both going to increase the feed to the FCC and improve the feed quality. Next slide, please. In which you see, this is the case by the numbers here. The graph on the left, we have a 1% increase in propylene make, which sounds small, but actually on a mass basis, it's a 75% increase in propylene production, just from boosting the feed quality and the throughput through the FCC. You can see the economics on the bottom there. Let's go to the next slide, please. So case number 2 is again a FCC coker-based refinery. Again, same configuration. We're adding the SDA unit here, but we're not adding the pre-treat. Instead, we're revamping the Maxifin unit, or sorry, the FCC to a Maxifin unit. And what that's going to do is really boost the propylene production quite a bit higher. We're also adding an ethylene recovery unit and a KSAT unit as well. Next slide, please. So by the numbers, you can see the overall yields for the refinery. We get a 3% increase in overall yield of propylene, and this is chemical grade olefins too. It's actually ethylene propylene mix. We get a 3% increase in light olefins make. It's actually a 320% increase of petrochemicals production over the base case. So quite a bit additional capacity added. And that's from the high quality DAO from the ROSE unit from the SDA and from the Maxifin technology boosting to 20% propylene make over that FCC. Next slide, please. So the last case is a little twist on the last one. Here, instead of a 2-product ROSE unit, we're taking a 3rd product. And that is separating the DAO into an LDAO fraction, a light DAO, and an HDAO, a heavy DAO fraction. The light DAO is actually really resinous, and it's suitable for lube production. So we've actually got a lube complex added here that's producing a high-value lube oil product. And then the HDAO is going to the Maxifin unit to boost the petrochemicals production. Next slide, please. So if we look at the numbers for this case, again, we get a boost in petrochemicals from 1% to 4% over the base case. If you look at the raw increase in mass, it's 300% increase in petrochemicals production. We've also got the high value lube oil production added to this case. And you can see, the numbers on the bottom, quite a big uplift in margin, $6 per barrel. And the IRR is 21+%. Next slide, please. To show the fullest extent of KBR's technology, here we have several configurations for crude oil to chemicals. And again, these are major capital investment projects. We'll be going to most likely to full derivatives production. And you're talking about, on a conversion basis, upwards of 60% conversion of crude to chemicals. So the scheme or configuration on the left features KBR's SCORE and KCOT conversion technologies. The scheme on the right features KPRO, SCORE, and Maxifin. Next slide, please. Just a couple of closing thoughts before we answer some questions. So change is coming. Excuse me. Change is coming, and really change is here. I think we're seeing an accelerated amount of change since the pandemic started, and really a proactive approach is what we recommend to refiners looking to integrate to gain an edge for the future. There's no one size fits all solution for integration, and KBR's technologies can offer unique or uncommon solutions to fit your challenges. We've got a large portfolio that I think will suit most, if not all, challenges that you may face in integrating. All options should be explored. So whether it's creative investments, partnerships, looking at derivatives production, we encourage to look at all options. And finally, KBR has proven technologies, a broad integration toolbox. And with that, I thank you for your time. I think Luis, we have some questions, and we'll take those now.
Okay, Brian, thank you very much for your presentation. Very interesting, in particular for people like me coming from refinery. But in these times, always practically, refineries are constrained in capex, in particular in the last time because of the quality upgrading to accomplish environmental rules and so on. So, what are some low capex or high return configurations that you might recommend using KBR's existing technology?
Yeah, it's a good question, Luis, and I think capital is very constrained right now, and so I think one thing that we talked about that helps with these projects is phasing your investment. And certainly, you have to look at what you have in the refinery. So if you're an FCC centric refiner, there are some phasing options, and we covered one sequence that you could follow for that. So potentially adding a secondary riser, doing what you can with the gas plant for the first phase, and then the second phase really modifying the gas plant and maybe even adding cryo separation to produce a higher purity olefin product. So the FCC I think is an obvious one for a low capex phased investment that seems to work well, and a lot of refiners are looking into that. The other options, I think, boosting feedstock to an FCC. If you have some room in your FCC to increase feed, I think pushing more low value to high value. So taking an SDA unit, as we used in our examples, is a lower capex project to upgrade residue. And if you have room in your FCC or even hydroprocessing capacity to make more naphtha, which is a petrochemicals feedstock, that's a low cost way to go from residue to either chemicals through an FCC or a chemical feedstock naphtha.
Okay, thank you. Although I have my preference, I would like to ask you aromatics or olefins? What is maybe the better path for a refiner to start improving the integration to petrochemical?
Yeah, that's another good question. I think if you look at the market over the last few years, I think you can see that aromatics has been somewhat challenged. I think there's a lot of supply, a lot of added capacity out there that flooded the market and really has put some downward pressure on those economics for aromatics. However, I think we have seen a lot of cyclicality in aromatics, so it it's not to say that it may not come back around the other way. I think if I had to make a comment on it today. I think the olefins market and the derivatives associated with light olefins is a stronger economic path. But I think it's important for each refiner to look at their own unique situation to conduct a market study. I think is a very useful exercise to understand what your unique market looks like.
From your perspective, Brian, is Latin America an area of opportunities for start thinking or start working on this integration? Do we have room based on the service that you made?
Yeah, I think for Latin America, I mean, in particular, when you look at the existing assets within refineries, so a lot of the refiners have FCC units, and as such, make them well oriented to boost petrochemicals make, and those refiners within FCC are at an advantage over other refiners that maybe are hydrocracking centric, that don't have a conversion technology to olefins, or maybe less FCC capacity. So an FCC centric refinery that's making a lot of gasoline is well positioned. And as we look at Latin America, that's the predominantly many of the refiners have an FCC unit. So it makes them well positioned already to shift to petrochemicals.
Okay, Brian, thank you very much for your presentation, your answers. On behalf of APLA, I would like to thank you for the support, and thanks all the audience to be here this afternoon. Thank you, Brian. Thank you all.
Thank you.